In this video, we're going to take a look at some worked examples of problems involving matrix row operations. So we're given a system of linear equations. There's three unknowns, x, y, and z, and we've three equations. So as we saw earlier, we can write an augmented matrix which represents this system of equations. And then using the row operations, we're going to change this matrix into one that looks like this. And once we've achieved this matrix, then we can say C1 is x, C2 is y, and C3 is z. So that's our goal, and we're going to use these operations to achieve our goal. So here's our system of equations, and here's the augmented matrix which represents these. Now, my first goal is to have a 1 in the top left corner. So I always need an order in which to go about these problems. Always start in the top left, and then work in a general anti-clockwise manner. That's the rule of thumb anyway. So my first goal is I want to have a 1 here in the top left corner. Several ways of getting there. How I'm going to do it though is to swap row 1 and row 2. So now we can see that swap has occurred. Now my next goal is to change this value into a 0. So how I'm going to do that is to say row 2, and I'm going to take 2 times row 1 from it. So we take a look at that math. So we have 2 row 2 minus 2 times 1. That'll give me a 0 in my new matrix. Then I'll have minus 1 minus 2 times 1. So minus 1 minus 2 times 1, that's going to give me minus 3. And my third element in the row, I have 2 minus 2 times 1, which again is 0. And finally then I have minus 6 minus 2 times 0, which is still minus 6. So my top row will be unchanged, my bottom row will be unchanged, and the middle row will now look like this. So this will be my new matrix. And now my next goal is to change this element into a 0. So to achieve this, I'm going to say row 3 minus row 1. So now I'll have row 3 minus row 1, that'll give me a 0. I have 2 minus 1, that'll give me a 1. I have minus 2, and then minus 1, that'll give me a minus 3. And finally then I have 8 row 3 minus row 1 minus 0, and that'll give me 8. So my top row is unchanged, my bottom row is unchanged, and this is what my new row 3 will look like. So now my next step is it easier to change this into a 0 or to change this into a 1? I can't use row 1 though, because if I try and use row 1 in any calculations, this 1 here will come in and break my zeros that I've so carefully lined up in the previous slide. So my next step, I'm going to change the middle element into a 1. And how I'm going to do that is simply divide across by -3. So this will divide row 2 by -3. So this divided by -3 will give me 1, and this will give me +2. And here's my new matrix. So now I take a look, I've got my 1 in the middle. So my next goal now, I want to change this value into a 0. And how I'll do that is, again, I can't use row 1, even though it's got a handy 1 there, but I can use row 2. So I'm going to say row 3 minus row 2. So now 0 minus 0 is 0. 1 minus 1 is a 0. I have -3 minus 0 is -3. And then I have 8 minus 2, and that gives me a 6. So this is my new row 3. Row 1 is unchanged and row 2 is unchanged. Now my next step, I'm going to change this value into a 1, and it's achieved quite easily. Simply divide row 3 by -3 again. So again, this will go to 1, and this will go to -2. And this is my new matrix. So now normally I'd go to change this element into a 0, but it already is a 0. So I've actually saved myself a little bit of work. So my next step is to change this element here into a 0. So how I'm going to do that is to subtract row 3 from it. So we're going to say row 1 minus row 3. So again, it's going to be 1 minus 0 is 1. 1 minus 0 is 1. 1 minus 1 is 0. And then we have 0 minus -2. So again, always be really careful with your minuses. That gives us a +2. So this is my new row 1. Middle row is unchanged and bottom row is unchanged. And now I'm nearly there. I just have one last element to change. I want to change this element here into a 0. And how I'll do that is by subtracting row 2 from it. So we're going to say row 1 minus row 2. New row 2 is going to look now row 1. So it's going to be 1 minus 0 is 1. 1 minus 1 is 0. 0 minus 0 is 0. And 2 minus 2 is also 0. So this is my new top row. My middle row stays the same. And my bottom row is also unchanged. And now I've actually achieved the solution matrix. I can unaugment it from here. And when I multiply everything out, 1 by x plus 0y plus 0z is 0. And I get my three answers like this, x, y, and z. So now we take a look at another example. Again, it's a 3 by 3 matrix. Sorry, it's a 3 by 3 system of equation, which gives us a 3 by 3 matrix here. This is our augmented matrix. It's got all the information from the system of equations. And using our rules, we're going to convert our augmented matrix into this form here. And from there, then, we can define x, y, and z. So we'll take a look. We start with our system of equations. we augment it, turn it into an augmented matrix. And you can see again, always at this stage, just pause, check that all your minuses are correct, that everything is accounted for, because a small mistake here is going to have you pulling your hair out in frustration in a couple of slides time. So just take your time. And now my first goal is to have a 1 in the top left corner. So again, there's several ways I could try if I wanted, and it's perfectly fine. You could say row 1 minus row 3. I'd have 3 minus 2, that'd give me a 1. Everything else would change. That's a valid path. But what I'm going to go for something simple is just swap row 1 and row 2. And that gets us here. Now my next goal is to change this into a 0. So it's always the same pattern. Start in the top left and start working anti-clockwise. So we want to change this 3 into a 0. And I'm going to use row 1. We'll say row 2 minus 3 times row 1. And again, that's 3 minus 1 gives me a 0. 2 minus 3 times minus 3. So this again is another area. So this is actually 2 plus 9. So that gives me 11. Then I have minus 1 minus 3 times 1. Minus 1 minus 3, that gives me minus 4. And finally then I have 5 minus 3 times 8. And that'll give me 5 minus 24. And that'll give me minus 19. So this will be my new middle row. Top row will be unchanged, bottom row will be unchanged. And that's us there. So now, my next goal is to change this element into a 0. So I'm going to do it using row 1. So we'll say row 3 minus 2 times row 1. So it's row 3 minus 2 times row 1. Yeah. So it's 2 minus 2 times 1. So that'll give me 0 for my first element. Then we have 4 minus 2 times minus 3. So that'll give me 4 plus 6, which is 10. Then we have 1 minus 2 times 1. That'll give me minus 1. And finally we have 4 minus 2 times 8. So that's 4 minus 16, which leaves us with minus 12. And again, watch your minuses. So that's my new bottom line. Middle line and top line are unchanged. So this is what my new matrix will look like. And again, my main goal is just to have this 1 and a 0, 2 zeros in the left hand column. That's my goal. Everything else will sort itself out as we work our way along. So here's my new matrix. Now this is always the turning point of the problem. Your goal from here is, do I change this value into a 1 or this value into a 0? And remember, we can't use rule 1 anymore, or row 1 anymore, because this 1 here will break any zeros that we've just created. So I can see I have an 11 and a 10. I'm going to change this into a 1 by simply saying row 2 minus row 3. So now Row 2, I have 0 minus 0 gives me a 0. I have 11 minus 10 gives me a 1. Minus 4 minus 1. So that's minus 4 plus 1. That gives me a minus 3. And finally, I have minus 19 minus 12. So that'll be minus 19 plus 12, and that gives me minus 7. So this is my new row 2. Row 1 is unchanged and bottom row is unchanged. So now I'm beginning to get there. The matrix is beginning to take shape. My next step, remember always trying to work in a general anti-clockwise motion, I want to change this into a 0. So how I'm going to do it, the only row I can use is row 2 above. So I'm going to say row 3 minus 10 times row 1. So row 3 minus 10. So 0 minus 10 times 0 is still 0. 10 minus 10 times 1 is 0. That's our goal. Minus 1 minus 10 times minus 3. We better write that down. So this is actually minus 1 plus 30. So that gives me 29. And finally then we've minus 12 minus 10 times minus 7. So again, lots of minuses, but just be careful, this becomes minus 12 plus 70. Minus 12 plus 70 is 58. So this is my new row 3. Row 2 is unchanged and row 1 is unchanged. Now my next step now, even though the numbers look awkward, guys, hopefully you'll see there's a nice easy relationship between these two. My next step is to change 29 into a 1. And how I'm going to do that is simply divide both sides by 29. So we divide to 29, we'll get 1. When we divide this by 29, we'll get 2. So this is my new row here. So now the matrix is really beginning to take shape. Like we've got it 2/3 in our kind of desired identity shape. So the next thing I'm going to take a look at is this minus 3. I want to change that into a 0. So how I'm going to do that, the only row I can use is row 3. I'm going to say row 2 plus 3 times row 3. So we'll have row 2, 0 plus 3 times 0 is 0. 1 plus 3 times 0 is still 1. Minus 3 plus 3 times 0 is 0. And we have minus 7 plus 3 times 2. So that's minus 7 plus 6. That leaves us with minus 1. And this is my new middle row. Top row is unchanged, bottom row is unchanged. And this is what we'll be bringing on to the next page now. So now my next step, I want to change the top value into a 0, top right. So notice all of this is sorted now, as well as the 1, So I'm nearly there now. I want to change this top right value into a 0, and I'm going to use row 3. So we're going to say row 1 minus row 3. So we're going to have 1 minus 0 is 1, minus 3 minus 0 is minus 3, 1 minus 1 is 0. That's our kind of goal in this one. And then we have 8 minus 2, that leaves us with 6. So this is my new top row. Middle and bottom row are unchanged. And now, last element, I want to change this element into a 0. And I'll use row 2. We'll say row 1 plus 3 times row 2. So we have 1 plus 3 times 0 is still 1. Minus 3 plus 3 ones is a 0. Minus 3 plus 3 is a 0. We have 0 plus 3 times 0 is still a 0. And we have 6 plus 3 times minus 1. So that's 6. That's 6 minus 3, which leaves me with a 3. So that's my new top row. Bottom row and middle row are unchanged. And now I have my identity matrix on the left. So I've achieved my goal. When I unaugment this matrix, I can turn it back into a system of equations. And here we'll have this row by our variables. We'll end up with 1x plus 0y plus 0z is equal to 3. 0x plus 1y plus 0z is equal to minus 1. So y is minus 1. And finally, z is equal to 2. And that's our solution. So they do take a bit of practice, but it is worthwhile when you do get one out. There's a feeling of achievement as opposed to the feeling of frustration if you make a mistake. So give them a go, folks, and we'll finish up here. So thank you for your patience and for listening.